All right, hey everyone. So hope everyone's week is going well. So this is my favorite topic. So I think today is going to be really fun. So today it's going to be all about cross-site scripting. So this is if you remember last time we talked a little bit about the server sending back this response, which was sort of used in an unexpected context, which was like inside of a script tag, and that could cause the content to be run as JavaScript, and that might cause issues. This is similar to that. It's about code and data sort of being mixed in a way that they're not supposed to be. So before we start, I want to just tell a story. So there was this. I think you brought up MySpace last time, right? So this is a pretty amazing story of a worm that spread throughout MySpace, and let's just go ahead and read the story and see what goes on. So this is from the write-up that this guy Sammy did afterwards. So he noticed that he could include a little bit of extra code in the box where you type in your profile information, and that code would actually get included in the resulting page, and it would run in the user's browser. And so naturally, he decided to make people who viewed his profile automatically add him as a friend. So he included a little script that would just submit a request, and then he would have a new friend. So he also realized that it would be more fun if instead of just adding him as a friend, he also added a script to their profile that would do the same thing. So if you view his profile, you're now going to have the code in your profile, so anyone that views your profile will add the same dude as a friend. So you can see where this goes. This is his sort of diary of how it went. So in the beginning, he had 73 friends, and he released the program. An hour later, he had one friend request, so not too successful there. But then 7 hours later, he had 221 friend requests and was pretty surprised, and I guess didn't really understand how exponential growth works. So eventually, an hour later, he had double that, and then an hour after that, he had 500 friend requests and started getting messages from people who were really upset at him. They were like, why did you add me as a friend? They also tried to remove him as a friend, but if they viewed their own profile, they would re-add him as a friend again. So it was like really bad. And he also added, since he added this text to their profile, he was able to sort of insert arbitrary text. So he included this string, Sammy is my hero. And so sort of throughout MySpace, this message started appearing on profiles everywhere. And let's see, so then it just goes really crazy. 5 hours later, he has almost 1 million friend requests. And you can see here at the very end, I love this. He refreshes, and in 3 seconds, he's gained like 1,000 friends. And then a couple seconds later, he has over 1 million. So yeah, pretty amazing example of cross-site scripting to make a worm. This is pretty cool. Now, if you're from MySpace's perspective, and from your perspective when you're building web apps, this is what you want to avoid. So then at some point he refreshes and notices that the whole site is down for maintenance. And this goes on for a few hours. People can't load their profiles. Nothing is working. Probably my guess would be because of the volume of requests that are being generated. Like viewing a page now causes a couple of requests to get fired to do extra things like add him as a friend and stuff. And that sort of probably just doubled their load in a way that they weren't expecting, and the whole site went down. So yeah. And then a few hours after that, they got it fixed, and the program was removed. So I'm guessing they probably ran regular expression across the whole database to just strip out his code. But the remnants remained, and you could still see Sammy is my hero on like lots of people's profiles after that, since they didn't remove that. So it's a pretty epic story, I think. What is the reason why an attacker would use cross-site scripting? Well, so the goal is they're trying to run code in the context of some site that they're trying to attack, right? And so we already talked about how this is not allowed. It's not possible for me to frame my bank's site and then to reach into that and sort of, let's say, add a listener on the login form and then run this function whenever the user clicks login in their bank, and then pull out their username and password, because we can't cross this boundary into this other origin because of the same origin policy. So we need some other way to get our JavaScript running in the page we're trying to attack. So that's what cross-site scripting is all about. It's a code injection vulnerability, and this is basically caused whenever you have untrusted user data that's being combined with code. the code is usually going to be written by the developer. So this is you building your website. And obviously, in order to make a page, you're trying to combine this code that renders your page with some user information. So maybe you're going to display the user's name, or you're going to display some bit of data that the user gave you. And so you're sort of concatenating or combining these strings together. And it's really important when you do that that you don't let the user's data become code unintentionally. And that's the source of this bug. So yeah, this is anywhere where you see that you have data coming from the user, and then you're sort of inserting that into code that you wrote, you need to be wary of this. So one place it happens is cross-site scripting, which is what today's lecture is about. But there's another place it can happen, which is really common. It's just called SQL injection. And this is the same idea. It's when the user provides some data, and then that gets added to a SQL command, which is a command sent to a database to retrieve some data. And then that user's data modifies the command in some way to fetch different data, or to maybe run a second command after the first command, or something like that. So what's the big deal? So I mean, the point of this is that once the attacker gets their data into a place where it's interpreted as code, now they're able to do anything that they want, as if it was code written by the developer of the site. And so, I mean, as with all these sort of client-side attacks, the idea is that we're doing this in a user's browser, and that user's logged into a site. And so we can take actions, the attacker can take actions that look like they're actions that the user did. Right? So that's what Sammy did in that example. He was sort of sending a post request to the server saying, modify my profile. And then the cookies were attached. And then from MySpace's perspective, that's the same thing as the user actually modifying their profile and sending a request to do that. Right? Another thing you can do is, I think I mentioned this before. I mean, stealing someone's cookie is a very easy thing. If you look at the document.cookie object, you get that string. It's actually a string. You get that out, and you just send that to the attacker's server. If the attacker just sends that off to their own server, now they have a cookie that they can add into their own browser to basically become that user, right? So that's the other thing you can do. Does that make sense? Okay, so yeah, this is really bad. So let's go through just like a really naive example. If you've started the homework already, then you'll have already sort of seen this in the very first problem. But by the way, the homework is also, I think, really fun. It's basically you're an attacker and you're trying to attack your competitor's website. So you're like a startup and you have a competitor and they launched before you, and so you're trying to like make them unlaunch their site by like attacking it and convincing them to unlaunch it. So the idea is like we have this search page, and let's just be really naive here and see like what would be like sort of the wrong way to do this. So the user is going to do a search for flower, and that's going to navigate them to this URL here, and straightforward, right? And so now the server is going to get a request for this. It's going to pull out the query parameter, and it's going to see the input is this, right? It's going to retrieve that variable, and then it's going to just sort of concatenate it with this HTML. So this part here and this part here is hard-coded by the server, and then this part here comes from the user. Okay, that makes sense. Now, what would we do if we were malicious? Well, we're going to put a script in as our search, and we're going to hope that when the page is assembled, that script's going to run. So how does this work? So say we actually type that into the search box. So the browser will helpfully, so that's a form field, right? So when we actually hit submit, the browser is going to send us to this slash, I guess it's just slash in this case. It's going to send us to slash, which is just the same page we were on. But it's going to tack on the contents of the form. In this case, the input is called search, and this is the thing we entered in. But it's going to URL encode it. So this is just, that's this sort of percent and then a hex byte here. And that's just so that certain characters which might be ambiguous or considered to be part of other parts of the URL don't get confused as those parts of the URL. So example, say say this value contains an equal sign, right? That would be very confusing because here the key and the value are separated by an equal sign. So we can't have an equal sign in the value. So characters like that need to be URL encoded, and that's just what this is here. There's a few other ones, like in this case, the angle brackets are also URL encoded. But yeah, anyway, the point is when the server gets it, this is not sort of a permanent transformation. the server is actually going to undo that change and get back the original string, and then it's going to combine it with that same template we saw before, and we're going to end up with this as our resulting HTML. And of course, this is a problem because the browser doesn't know that this string came from the user. As far as it can tell, this is the server sending back a page and saying, this is my page, and this code is going to run. And so in this case, all we're doing is just sort of alerting out the user's cookie, which is not going to do very much damage. But this is a common thing you'll see in cross-site scripting examples. It's sort of demonstrating the fact that like the attacker was able to run code. In this case, just open up an alert, which is a little pop-up that just contains the user's cookie. Obviously, in a real attack, attacker would just send that cookie off to their own server or something like that. But if we do this, we can sort of just prove that there's a vulnerability without doing any damage. So if you're ever sort of looking for cross-site scripting attacks, a string like this is really nice to do because you're only attacking yourself in this case. You're literally just alerting your own cookies out to yourself. So no harm is really done. If you're just doing something like this where you're putting it into a URL, you're sort of just, attacking your own browser. Does that make sense? OK, cool. So yeah, so what do we do here? What do we think we can do to prevent this? What's something we should do? Any ideas? Yeah, in the back.
You test, you reject you put like a regular expression before getting putting the thing on your website to check if there's like script or something like that.
OK, so you're thinking if we see like an angle bracket script, we should just give them an error page instead of letting them see the search results? OK, that's reasonable. What if I'm a developer, though, and I actually want to search for like script alert? Like, shouldn't I be allowed to do a search for that? I mean, okay, you could say, I don't support that on my search engine. That's fine. Actually, you'll see some banks will actually, I don't know if you've ever seen it, a couple of banks will actually use that as sort of their defense for when you're like making an account. They won't let you make your username be any like programmer-sounding words. Like seriously, like if you try to like name your username like script or select or insert or anything that sounds like it's programmerish, they'll just say like you can't choose that as your username. And hopefully they're not relying on that for their security because that's a blacklist it's like a block list approach where you basically are saying I don't allow these things, but of course if you've forgotten one thing then you're owned. So you want to have like other defense mechanisms in place. Denying is one option, but what about something else? Any other ideas? Yeah?
Can you kind of convert the input that the user gives to a string so that it's not interpreted as a script in some way?
Yeah, that's the right idea. Yeah, so we want some way to tell the browser, like, hey, this is a script. This is not a script, but rather this is just text that I want you to sort of display to the user as literally like angle bracket, script, angle bracket. Like I want it to show up as, I want the user to see search result for, and then I want the user to see this text on the page. I don't want it to be executed, right? And so yeah, the way we do that in HTML is, fundamentally the problem is that we have these characters have significance in the context that we're putting this string in right now. And so we need to somehow do something to this character to sort of like neutralize it and make it not be treated as the beginning of an HTML tag. That's the problem, right? So that process is called escaping. I'll show that in a second. But first, this is that string that I kept showing before. And now you should understand what it's for. This is like the way that the attacker could. This is something that they could do instead of just alerting the cookie. They could make an image in JavaScript that just hits this URL, and then this is actually not going to show an image or anything, but it's just going to cause a GET request to go to this URL with the user's cookies. So now you actually know what that string is before that I was showing. And this is what that page would look like with that code in it. Yeah. So before I show how to escape it, let's first just like see it in action. So I'm going to go take us back to our bank site again. This poor bank has all these security problems. So what we're going to do is we're going to go to the code we had before for this, which is, let's see, where do I have this? Here it is. OK. So this is the same bank site we had as before. What I'm going to do is I'm going to introduce an XSS vulnerability into the site. But let's think of something that's sort of a plausible scenario. So let's say that we want to add, so our bank is doing a partnership with a blog, and that blog is going to write a great article about how cool our bank is. And we want to track whenever somebody clicks that link, comes to our page, we want some way for us to just look at the URL and know that they came from this blog. And we want to sort of welcome them and say, hello, like Wired magazine reader, like welcome to our bank. So what we're going to do is we're going to add a parameter into the URL called source. And we're just going to pull it off of the query. So literally what that means is if I go to the bank site here, and I don't know if you all can see this right here, but it's going to look like this. I'm just going to sort of have a parameter that's like Wired magazine or whatever. And we're going to go ahead and use that to sort of change the text that the user sees here. OK. So we got that string, and now I'm just going to sort of add it to the page here. So let's only do it if they're not logged in. How about that? So if they come and they haven't signed up yet, we'll welcome them. So we'll say hi source reader. OK. Now the thing is, this could be undefined. So let's handle that in case there's no parameter, and we'll just sort of I'll do another nesting of this. If you don't understand this syntax too well, don't worry about it. It's not a big deal. But basically what this is doing is it's just saying, if source is defined, then say hi source reader. Otherwise, say nothing. Just don't say anything. OK. So I think that's it now. Yeah, now we can just go here and refresh this. And there we go. It welcomed us. Awesome. OK, so the problem, though, is, of course, we didn't do anything to clean up this string. This is an untrusted string provided by the user, right? By the way, quick side note, how would an attacker actually, well, OK, I'll come back to that in a second, actually. Let me just show the attack. So the attack is, of course, we just put a script in here, and we'll alert the document.cookie. OK, and so if we do that, and I hit enter, then I guess I don't have any cookies set because I didn't log in. But yeah, so it alerted. So let me just log in really quick and just prove that this works. OK. Oh, then again, if I'm logged in, then I'm not going to see the. OK, so we have some problems here. Yeah, the problem is basically that I'm only showing it when they're logged out, right? So I didn't think that through very well. I have an idea. Let me just go ahead and manually just set a cookie here so we can see that this is working. So I will just add a cookie called, something, session ID equals 1, 2, 3, 4. OK, so now we have a cookie. And now if I add that source equals Wired magazine again, there we go. And if I add the alert version, I'm not going to see my cookie there. OK, so that's not good. And what's interesting, though, is notice that script doesn't actually show up, right? And why is that? That's because it's being executed, right? It's being treated as part of the page. So if I actually open up the HTML here and we look at it, what do we see? We see that, well, I mean, it's just like before. So the script got inlined there in the page where the name of the magazine or whatever the source parameter should have been. And so yeah, the browser treated it as code and ran it. OK, so how would an attacker actually get a user to run this code, right? Because right now I just attacked myself. That's not a big deal, right? That's not going to do anything. So what would an attacker actually do in this situation? Yeah.
Do you just send them the link with the script and it just sends it?
Exactly.
It just runs the script and it appears you're on that page. Exactly. So if you get them to click that link, then this code just runs, right? So that's the thing that's really sort of pernicious about this is you might think, oh, I'm clicking a link to a site I trust. Oh, it's just like I'm going to Google, right? But if the site itself is vulnerable and you're logged into it, then the attacker's code still runs in that context and steals your cookies, and therefore it steals your account, basically, right? So you can't. It's not a defense to sort of not go to suspicious links. You're still in trouble if the site is vulnerable. So this is really bad. The other problem too is maybe you'd think, oh, well, I'll notice that in the URL. I won't click a link that has like a script tag in the URL. but a lot of times these days you're clicking links on mobile devices where it doesn't show the full URL or stuff like that. So it's actually sort of still pretty prevalent for that reason. Yeah. So basically, I'm going to show you how to fix it really quick. So one really quick way to fix it is there's a package called HTML escape. And I'm just going to import that really quick. And so what this does is it sort of goes through and replaces the characters that are unsafe with safe versions. And so now if I refresh this page with the script in it, instead of it alerting out my cookies, it should just display me the script, which is exactly what I wanted, right? I want to just show the user what was in the URL. So now this is not an attack. Even though it looks sketch, it's not actually an attack. So now if I look at the code, what actually happened? Well, that first angle bracket was replaced with what's called an HTML entity. And that's indicated by the starting ampersand and the ending semicolon. And then between that, we have sort of these characters that indicate what character the browser should show. So in this case, the LT stands for less than. So the less than sign, or the angle, left angle bracket is what we're going to get there. And again, this one was also replaced here. And just that replacement right there was enough to sort of neuter or neutralize this script. Mm-hmm. So I only ran that function on one particular variable, which was the source argument. So this is that string that was provided in the URL, and I just did it to that. Yeah, if I were to do it to the whole page, we'd have a problem, because then literally every tag in the page would just get shown to the user as text, right? And so I don't want to do that to all my tags, just to things which I know are not supposed to be tags, if that makes sense. Yeah, and so by the way, most of the time when you're doing this, you're actually going to be, you're not going to be calling a function like this, but rather you're going to be using some kind of a web framework which does this for you. So if you're using any kind of framework at all, typically you'll have a way of inserting data that comes from the user into your HTML template, and that mechanism will handle this for you. Though it will usually also offer a way to opt out if you don't want it to mess with your input, because you say you know it's HTML and you want it to actually be treated as such. There's sort of a way to opt out of it, basically running this function for you. And that's dangerous, but you can do it. But you need to be aware of sort of the implications of that. Yeah?
For example, like we're using Express.
Mm-hmm. Yeah. So if you're using Express, Express itself doesn't actually do this sort of the concatenation of HTML with user data, but you'll have a templating language. You'll have a templating language that you're using with it. And so like a popular one is EJS, or another one is Jade. Whatever. The point is, whatever you pick, when you look at its documentation, it will tell you, like, here's how you take data and put it into HTML safely, and then here's this other way which hopefully has a scarier name or is like harder to use that will let you sort of let you opt out of running this function. But yeah, usually you should just use the mechanism provided to you by whatever framework you're using. Yeah. Yeah.
And like in those frameworks, do people still manage to find like exploits nowadays, or are they like less common for XSS?
That's a great question. So I was looking up stats to answer this question, and I from what I can tell, it's just as common as it ever was. So I have a graph of it in here of how common this stuff is, and so for a long time XSS was like number one. It's still basically like half. I guess this adds up to more than 100% because sites are vulnerable to more than one thing. So, but like half of sites have XSS problems, according to this research, which is from I think it was called White Hat Security was the company that put this report out. So yeah, it seems like it's just as prevalent. And this is from, I think this is from like 2015 or 2016, so it's like relatively recent. Yeah, I think the issue is there's actually quite a lot of stuff happening on the client side now, like with React and all these kinds of frameworks, and so they're introducing kinds of different new ways of doing cross-site scripting that are we're less good at. We haven't figured out ways of solving as well yet. Yeah, so I'll have some examples of that too later. Cool. So yeah, basically the big idea here is never trust the client. Like this is something I mentioned before, but in this case it's the same thing, right? We get data from the client, we can't trust it, so it's suspect, and so we have to sort of clean it up before we use it. So why is it so prevalent? So there's like a lot of reasons for this. One is that the web has like so many different languages and different contexts that you can be in. So I mean, you have HTML, and then inside of it we have JavaScript, right? In certain tags, and then inside of that we have like strings that we might be putting user data into. And so there's all these different rules for each of those levels of what characters need to be escaped to be safe. So that's one big source of this. It's just confusing. And we're going to talk about some of these contexts that HTML has and the different rules for them and the different ways you can if people make mistakes, how you can attack a site with that. And yeah, and each of these contexts, like I said, have different control characters, and some of them have really complicated rules. And then, like with all things with defense, if you make one mistake, then it's game over. So it's really bad. But first, there's two general kinds of, well, actually there's three kinds, but we're going to initially just talk about two kinds of XSS. There's reflected and stored. So reflected is the idea that the attacker is going to place some kind of code in the HTTP request itself. So this is what we saw with all the examples we've really seen so far. So you're trying to find some kind of a URL that you can get your target to visit that includes the attack code. So one big limitation with this is that you have to find some way to get that attack code into the URL path or the query, or some way that is sort of effectively in the link, right? So it's somewhat limited in that sense. If you can't find a way that those things are being used unsafely, then you can't really do reflected XSS. On the other hand, so stored XSS is like what Sammy did on MySpace. So that's the idea is you're trying to get the code, the attack code, stored in the database of the server. And then the user who comes to the page can be coming from any URL. It doesn't matter if they clicked on your URL with your attack code in it, because the attack code is actually in the database of the server. And so when it renders the page, that code will be included, regardless of whatever URL they come from, right? And so yeah, so what makes this more powerful is that the attacker can use any means to get the attack code into the database. So what does this mean? This means like literally, like let's say I know that the server, this is a hypothetical thing, but let's say the server is looking at like an HTTP header and taking that value and putting it in the database. So there's no way I could send a link to my target and get them to click it and add an extra HTTP header to it, right? But so I couldn't do something like that with reflected. But with stored, I can actually like put whatever attack code I want in that HTTP header value, and if the server goes ahead and takes that and puts it into the database, and now they're just giving that to everybody who comes to the site, it doesn't matter that my sort of means of exploiting it was relatively obscure and involved an HTTP header. Does that make sense? As long as I could literally also, the attacker could literally just go and bribe somebody to add a script to the database, right? And that's also stored XSS, right? So it doesn't matter how you get the data into the database, or it doesn't matter how you get the attack code into the database. Does that make sense? Cool. Okay, so let's just look at this example here. So here we have some. I started playing Legend of Zelda: Breath of the Wild like 2 days ago. It's a really good game, so I just put the Wikipedia article for it in here. But yeah, so this is an HTML page, and this is untrusted user input that we just got from the user. And so the question is, how do we make it safe? And so for all these examples, I'm going to be using user data here to represent sort of an untrusted string that came from the user somehow, right? Okay. So so this is called our HTML template. So this just means that we have things that we wrote, code that we wrote, in this case the p tags, and then we have things that we didn't write that came from the user. And so that's an HTML template. So how do we protect this? We already kind of mentioned this, so we need to change all left angle brackets to this less than entity, and then the browser, when it sees this, it'll know that's not a real left angle bracket that I'm supposed to treat as the start of a tag. It's just something I'm going to just show in the browser, right? One problem though with this, can anyone see? Like this is not enough. We actually have to do one more character. Can anyone see what it might be? Yeah.
Can / escape the ampersand?
Can / escape the? What do you mean by that?
Like a / open angle bracket?
Oh, no. Yeah. So you're saying if the user types / left angle bracket, would our function, which translates all these into these, like miss that somehow?
Or would it translate that into / ampersand and then?
Oh, and that would somehow make this not work?
I guess it wouldn't make it left.
Yeah. So it would translate it into the / that, and then it would still do the same thing. Yeah, it would be fine. So what is the problem with all sorts of? Anytime we have a language and then we decide we're going to use one character as the indication of the start of an escape sequence, what's the problem that we've created for ourselves? Yeah.
You have to encode the ampersands.
Yeah. So.
We're doing that because I don't know if for some reason the user wanted to type LT like semicolon, you don't want it to be like confused.
Oh, if the user wanted to type, you're saying if the user typed LT semicolon?
Or
ampersand, yeah, exactly.
If the user wanted to type an ampersand LT semicolon, and
Yeah.
they wanted it to be
And they wanted that to show up, then what would happen is, right now, is it would actually show up as this, right? Because does that make sense? When the browser sees ampersand LT semicolon, it's going to show it as a less than, but the user literally typed in these letters and actually wanted these literally to show up. So this is sort of where you have to sort of go one level deeper in the inception, and we change all ampersands to ampersand amp and then semicolon, and now we've actually now we can represent everything we want to represent. So if the user types this in, we're going to get this, and you can think through it, and these two things are sufficient. You can just think through, it makes sense if you just think about it long enough. Okay, cool. So yeah, and then but one thing that's really important here is this. So it seems like we solved the whole problem, right? Like we just do this anytime we have data inside of HTML tags, but it's actually more complicated than that. So style and script have completely different rules. So we're going to get to that later. But for all the other types of tags, you can basically, this is your algorithm you can apply, and you're going to be fine. And again, when you're doing this in practice, you probably should rely on the framework that you're using to do this for you. But it's important to know what it's doing, and that's why we're going over all this. Because especially if you're a pen tester or you're an attacker, you need to. You're not an attacker. You're attacking your own site, or you're pen testing somebody else's site who's paying you to do so, and that you're authorized to be doing. Then you need to know what's actually happening and where the vulnerabilities come from. Okay, so let's actually see what happens here. So say now I take that same input that's malicious, and I run it through our new system. Again, like this is what we saw before. We get the replacements right there, and we're all good. Right? Okay, so now let's talk about a new situation. So HTML attributes. So attributes are these things, right? So that's an attribute name, and that's an attribute value. And so this is an image with an avatar, and then this is alt text. This is text that shows up if the user is using a screen reader, or if the user the image doesn't load for some reason. This text may show up instead. And so let's say that this text is untrusted. So what do we need to do to make it safe? Well, actually, first let's look at what would happen if we did nothing. So how would we actually attack this if we did nothing? So here's an HTML template that's going to swap in the user's data right here, and say that I made this my input. What's going to happen? Well, we can see. Does that make sense? So basically, everything between this quote and this quote is controlled by the attacker. So everything between that's this right here, this quote, and this quote. That's all attacker controlled. And so I can basically include a quote here in my input, which ends this value, and then I can just say, oh, actually, I want to add a new attribute here. And now, as far as the browser is concerned, when it looks at this, again, it doesn't know which part of this the user controlled and which part the site controlled. It's just going to see this and say, hey, that's an image tag that has 3 attributes: source, alt, and a function that I'm supposed to run when the image is done loading, right? And so this is going to run this code. Does that make sense? Cool. All right. So let's try to defend against this. So what's something we could do here? What characters do we need to be worried about in this context? Yeah. The quote? The quote. Yeah, the quote. Okay. So let's switch the quote to something else, right? Okay. Yeah. So let's switch single quotes to something else. That seems reasonable. One thing though is that so you're right. Let's do that. And then this is the HTML entity for that. But the thing is, you can actually use double quotes as the quotes that surround attributes in HTML. And since we don't know, we don't want to have separate functions for each of those. Let's just be sort of extra safe and just turn both types of quotes into HTML entities. And so now it doesn't matter what this is surrounded with. We're just going to sort of be a little bit over aggressive, and it doesn't hurt. It doesn't hurt to take a character and to sort of turn it into an entity. It doesn't sort of affect. You can actually turn every character into entities if you wanted to, and it would do the same thing. So does that make sense? Yeah.
Just really quick, I thought the HTML was being served to the client from the server.
Yeah.
So how are they actually, are they modifying the HTML that they've already received?
Oh, in this example here?
How do they actually get?
Oh, how are they getting their input into here? So this is that's a good point. So I guess, so we could think of this as a stored XSS thing. So let's say that so I'm making a new profile on a site, and it asks me what my name is, and instead of typing in Ferocibucadije, I type in that string from before as my name. And now what we're defending against is basically we don't want, when anyone comes to my profile, that it renders the image of my profile like this, because now we're going to be running code on that user's browser. So that's how our attack code gets onto the target's computer. Yeah. So okay. So we change those two things, and now when we put our attack input in, this is what happens. So now you can see the browser. What is it going to think now when it looks at this? It's going to think, well, okay, we just have some kind of a strange alt string here with an apostrophe in it. But it's not going to, this is not going to sort of end the context here and start another one. Does that make sense? Cool. All right. So that's so far not too bad. Now here's where it gets really nasty. So it's possible in HTML to omit the quotes entirely. So you can do this image tag here with no single quotes or anything around it, and this is totally valid. One downside of this is that you can't include spaces now in your values, because if you include a space, that's sort of going to be parsed as the start of another attribute. But this creates all kinds of problems now, because now, now I can just, even using our algorithm from before, where we swap out quotes for those entities, we've sort of owned ourselves, because now that doesn't protect us, right? This string here has no quotes in it. So the replacement did nothing, and we still got XSS. Does that make sense? So now there's a whole, now the question is, what characters do we have to worry about in this case? And the answer is a whole bunch of characters that you really don't want to worry about. So you might just think, well, okay, space is the only thing we need to worry about, right? Just don't let them put spaces in here. Then they can't end this value and start another attribute. But it turns out browsers have this sort of really lax parsing policy, and I'm going to mention a little bit more about that in a sec. But basically, any of these characters will be treated as effectively ending with this value and let you move on. So it's kind of a bad idea to do this. So just don't do this. Just always put quotes around your attributes, and then you don't have to worry about this problem. Make sense? Yeah, and so by the way, this for a long time was different across browsers too. So you couldn't even know, there was no sort of single set of things you could just escape, because every browser had its own rules. And now we've sort of gotten to a better place where it's standardized, but it's still a bad idea, I think. Okay, so just escape attributes. So there's one thing to mention though. So far we've been talking about these attributes like alt, which are relatively benign. The value here just affects some text that's shown in when the user hovers or uses a screen reader to access a website. But there are certain attributes which have more sort of power, for example source or href. So if you do something like this, script source equals let the user set this to what they want, you have a problem here, right? Because now you're letting the user effectively choose a URL that a script is going to get loaded from. So it's not enough to just be oh, well, I took the quotes out of it, so their string is now not going to break out of this quote here and do other things, but you forgot the fact that you're literally letting them load a script and run it, so it's game over already. So just keep that in mind. Does that make sense? Okay, but it's even worse than that. So you might think, okay, well, let's say that, let me see, what's an example here? Let's say you had some way to tell that the URL they're putting in here is safe. You have a regex or something, and you're I'm okay with them putting that in as the value or something like that. Probably a bad idea, but let's say you had a way to know that. Well, you have to be careful when you write that regex, because there's these other weird protocols called data and JavaScript, which can cause all kinds of havoc. So let's talk about those. So first of all, I'm just going to show you a demo of actually navigating to one of these URLs. So let's see. Let's open a new tab here. So actually, who's seen data URLs before? Okay, a few people have. What about JavaScript :URLs? Okay, yeah. So they're really, really rare. You don't usually see them. But yeah, so you can do this thing where you can say data. Can everyone see this? Data : and what I'm going to specify here is a MIME type. So I'm going to say I have an HTML page, and what do I want to put in it? Maybe I want to say hi. Okay. And if I hit enter, that actually loads a page. What is this doing here? This is really weird, right? What is this doing? This is this is saying, effectively, pretend that this is a URL to some server out there, okay? And this is pretend like we're making a request to that server, and then pretend that the response we're getting back is what follows the comma, and then pretend that its content type header is set to text HTML. Okay? So it's a synthetic response from a non-existent server, basically, right? Does that make sense? Okay, so one thing about this, though, is this means that if we don't strip out data URLs and we let people put that in and think that that's safe, well, we've literally given them, again, arbitrary script execution, because I can put whatever I want in here. I can say script, alert, I can't type, alert document dot, oh my gosh, I really can't type. Alert document dot cookie, and then close the script, and then if I run this, nothing happens. Why? What happened here? No cookies? Is that why? Let me try alerting something else. Okay, yeah. So I think it must have just been no cookies or something like that. Okay, so yeah. So let me say hi. Yeah. So that's not good. But by the way, one kind of interesting tidbit, you can actually use this for if you just need a quick notepad, like if you're trying to type something, but for some reason you can't open up anything but a browser, and you also don't have internet, and you need to type something, you can type this. Can everyone see this? You can make an HTML document and say content editable, and then this will load up a page, and what content editable does is it lets you just type. So you have like a little text editor. It's kind of cool. Yeah, pro tip. Anyway, so that's irrelevant though. Okay, so now I want to show you JavaScript URLs. So with JavaScript URLs, let me go to a page like this, and then we can use this as an example. So I'm on this page. And what JavaScript : does is it lets me basically run JavaScript in the context of the page that I'm in. So that's kind of weird. Let's see what this looks like. So if I say alert hi, but I started it with JavaScript : right? Now, when I hit enter, what's going to happen is it's going to actually run that code on the current page. It didn't actually take me to a new URL. That's pretty weird, right? So you can start to think about ways that this could be used to attack a site. Okay, so that's how that works. Oh yeah, one other tidbit. This is kind of funny. So let me go to a text document here, and I'm going to type JavaScript : alert hi, and I'm going to copy this to my clipboard, and then I'm going to go back to this page, and I'm going to paste it in. And what just happened? The JavaScript : was stripped out. What happened there? Anyone have any ideas? Yeah.
Is Chrome protecting you from yourself?
Yeah, Chrome's protecting me from myself. So the idea is this is actually a huge phishing vector. So the way that these attacks work are, say that you see some sketchy post on Facebook that says, copy this URL and paste it into your address bar to see who's viewing your profile or something like that. That's a common meme in these phishing attacks. They'll often put whatever code the attacker wants to run, and they'll prefix it with JavaScript : and if the person is silly enough to believe it and paste it in, then they're going to be running the attacker's code right in the page. And that's such a simple thing for a user to do, to copy a string and then paste it in their URL bar, that this was happening more than browser vendors were comfortable with. And so the solution was, well, we'll just if we see them pasting in the URL bar, we'll just sort of chop off the JavaScript : part to sort of save them from themselves. But the thing is, you can always go and add it back in. So if you add it back in, it works just fine. But I think that that's enough of a roadblock that it makes the attack less effective. That was the sort of idea anyway. But if you try to do this in other browsers like Safari, you get a slightly different behavior. So what Safari does is it tells you it doesn't allow JavaScript in the search field, but you can go turn it on in the settings if you want. And Firefox also follows Chrome's approach and just strips the JavaScript : part out. Okay, so we have these two really weird URLs. So what are we going to do here? So what are these for? So let's first talk about why, what are the legitimate. Oh, you have a question? Yeah.
Why are the JavaScript tags still around? Why not just get rid of it completely?
The JavaScript : thing? Oh yeah, I was going to try to mention the legitimate uses of it here, but I honestly argue that there's basically no reason to ever do this anymore. But I think it's for backwards compatibility with all the sites on the internet that were built before we had sort of better ways to accomplish these things. So here's an example. So say that you want JavaScript to run when the user clicks this link. You could say, okay, when the user clicks this, go to JavaScript : whatever code I want to run. And now I've effectively made a button with like a dynamic JavaScript behavior attached to it. Now, obviously, we know we can do this without this weird hack. We can just have a script tag that like listens, that attaches an event listener to the link, and then we can handle it that way, like we've learned in in basic web programming class. But yeah, this is another way to do it, and that was used a lot. The data URLs, by the way, these are actually useful, I think. So I guess, yeah, I take back what I said about data not being used anymore. Like, I've actually used this, actually. So this is actually relatively useful. This lets you save an HTTP request. So here's an example. Say you have a page, and like, the logo is always going to be requested, right? So you could just do image source equals the URL of your logo, but now the user has to wait for the HTML page to come to their browser, be parsed. The browser finds the logo, and then it sends out an HTTP request for the logo image, and then it gets that back. And so we've done this sort of 2 round trips before we can see the logo. Maybe I really, really care that people see my logo fast and it feels fast. So what I can do is I can sort of inline the image directly into the page, and so now they're going to get it with the first request. And it's particularly if this is a really small image, this makes a lot of sense. If this is a huge image, like 3 megabyte image, you don't want to do this, because now every time I click a link, I'm not able to use any kind of caching. Because I'm now like the browser's or the server is always sending me the HTML page with this like 3 megabyte image included in it, and there's no way I can utilize my browser's cache. But if this is like a tiny little image, it might make sense to just sort of inline it and save that round trip. This is actually used quite a bit. And then another one is the same thing. You can do the same thing in CSS. So you can sort of, rather than make an HTTP request, you can just sort of stick the image right there in the page. Does that make sense? Okay, so it's like relatively legit. Okay, so the problems here arise when we might think like, oh, we're making a site where we let the user select a link. Maybe we're building Reddit or something, so they can pick a link. Well, if they pick a link and we don't do anything to check that it's not a JavaScript link, well, then we've just given them XSS. So that's something to keep in mind. You should validate that it's actually a URL that's well formed before you stick it into this href tag. In addition to also making sure it doesn't have quotes. So there's extra things required when you're dealing with href or source. That's the lesson here. So for source, what do we need to worry about? So source, let's see. So for letting them pick like an iframe source, now we can, they can pretend that, they can give us this data URL that's actually a page that's going to run code. And I actually don't know what origin this is treated as. I would need to look that up. I don't remember off the top of my head, but it's possible this iframe actually would have its own origin, and this script wouldn't be able to sort of go up out of the frame and do something to that outer page, but I actually don't remember. And then, of course, this is really bad. This is, gonna just run. This is gonna treat this as a script. But yeah, this is kind of obvious. Cool. So, any questions? Just remember, it's not enough to replace quotes if you're putting it into certain attributes which are more powerful. Okay, so there's another gotcha with attributes. Attributes have a lot of potential attack vectors. So this is something that you'll see sometimes where somebody will say, okay, I want this function to run when the user puts their mouse over this div. Okay, well, we also want to put some kind of user data into this function here. And now it's obviously not going to be enough to just escape the single quote and the double quote, because this data here is inside of a JavaScript context in addition to an HTML context. So if we just escaped quote and double quote, sure, they're not going to be able to sort of end the quote and add additional attributes to this div tag, but they're going to totally be able to do this and just sort of end our function early. And then, so say they did this, they ended our function early and then they wrote their own function. Well, this is what's going to happen. It's going to produce basically 2 functions that are going to run on mouse over. Does that make sense? So yeah, all these things are really clever. But yeah, so basically here we have to do sort of different escaping rules. And I'm gonna mention how to do that with JavaScript in a sec. Yeah.
I had a quick question about actually the previous slide.
Okay.
Before this one.
Yeah.
The iframe one, where you let a user choose a page on iframe.
Yeah.
And then they can get it to return a script. Do you know what origin that's running from? I'm wondering how the origin policy relates.
Yeah, I don't know. I would need to look that up. Yeah, so that is a good question, though. If it was a different origin, then maybe this wouldn't actually be so bad. But the thing is, one thing though is, if they were to put like a while true in here, even if it was on a different origin, you still have like one browser event loop, and so they can lock up your whole page, which is not as bad as some kind of real security issue, but it is a kind of a denial of service. But yeah, we could look that up. I'm actually not sure. Yeah, if you want to look it up now. Okay, and so I said this was the one last gotcha with attributes, but then I realized there was one more right before lecture. So this one is wild. Okay, so you have to be careful when you're letting the user select the ID of an attribute. And I guess I shouldn't have put this up here because I wanted people to guess, but I guess it's probably too. Oh, no, I didn't put up the answer. Okay, good. Yeah, so say we let the user select the ID and they select username, and then we end up with this HTML here: div ID equals username, some text. How could this possibly cause an issue? Ideas? Yeah.
Can it get submitted as part of a form if it's picking things by ID?
So I believe that forms use the name field. Although that's a good point. I should probably also add name to this list, because if you're letting them choose the name in a form, then you have problems again. But no, so it's not that though for this. Yeah.
What if you have another ID which is similar?
Oh. Yeah, that's a good one. Yeah, so if there's, that's a good one. I didn't even think of that. If you have, the way IDs work, they're basically like classes. They let you sort of select elements, but you're supposed to have one per page. You're supposed to be unique across the whole page. So if you had two IDs, I actually don't know what the browser would do in that situation. It might return this instead of the thing it should return, which seems like a potential issue. Now it's not obvious how you turn that into an attack, but you certainly sort of changed what the JavaScript is doing, which seems like something that could be turned into an attack. Yeah.
There's some other JavaScript running that expects like a username div that has the canonical username in it and then uses that to print the username somewhere else.
Yeah, that's right. Yeah, you can exactly. So that's similar to what he said. So it's sort of like confusing the code that's looking for an item on the page that has an ID of username. Yeah, but there's one other thing, which is. Oh, did you have another one?
I actually didn't fully hear the first one, but this might kind of be repeat. But
Okay.
if there's like a script tag somewhere else that fetches that ID and then uses it in the code, like printing it or something, then if the username is like some kind of JavaScript, then it can do that.
Mm-hmm. That's right. Yeah. Okay. Yeah. Yeah, so the one I was thinking of was that HTML has this really bizarre feature where, sorry, it's not HTML, it's the DOM. I believe it comes from the DOM. What it does is any element on the page that has an ID, that name is automatically creates a variable in JavaScript with that name that's a global variable. This is not JavaScript's fault, but this is sort of the DOM. So it's the interaction between JavaScript and HTML. So yeah, I'm not kidding. So what this means is that if you do this, if you write this code, there's literally going to be magically a username variable which points to that. And so by letting the attacker or the user control the ID, you're literally letting them declare variables at the start of your script. So maybe that can be used as a way to change what the script is doing. In particular, here's something I just thought of where potentially, the username variable would normally be undefined except in certain situations. And so when they do that, now this is going to be true. And so you can do something, you can sort of fork them down a different path, which might help you in creating an attack. Yeah?
So is the user able to inject the script as well through that?
No. So the idea here is this is the script that the site author actually wrote. This is like fine. This script is totally fine. The only thing that the attacker was able to control is just the string between the quotes there, between ID quotes, and that allowed them to declare a variable here, which can alter the behavior of the totally valid script that's allowed to run. Yeah.
Is this ID specific or does it work on class as well?
I think it's just ID. Yeah, because class you have a problem of there are multiple per page. Although I guess it could make an array, but I don't think it does that. I think it's just for ID. Yeah. Okay, so let's keep going. So script elements. So this is going to seem like a really bad idea, but and it is honestly. But this is actually relatively common. So a site will often want to include some kind of dynamic user string inside of a variable in a script, and they want to make sure that this string can't alter what the script is doing. And this seems like really dangerous because we're literally putting user data into a script. We better be very, very careful about how we do this. So so let's see. So say this is our template. This was our template here, and that's where our data is going to go. And I make this my my input. So we can see what happens. It's not very good. Does anyone know why I'm putting the / in here? Yeah.
So you get a syntax error for the single quote at the end? At the end of user data here, single quote?
Yeah. So basically, we're putting this string into the middle of these quotes, and so it's important that that here at the end, this trailing quote doesn't cause the whole thing to not parse, and we get a syntax error, and then none of our code runs. But we can just use this comment here to sort of neutralize that, and then we have a valid script. We'll just stare at this for a bit. Does everybody see what's going on? So yeah, so to fix this, what could we possibly do? This looks kind of similar to something we've already seen, right? Look, we're trying to put user data between single quotes. So could we just escape the single quotes? Yeah, like we did before. Would that work? Seems like it, right? Let's see what happens if we do that. So yeah, let's change. Oh, but the thing is though that this quote is actually this is a JavaScript context, right? So in JavaScript, when you have a quote, if you were to put a quote in here, you're sort of ending the JavaScript string. So the way we escape it would be different, right? We would escape it with /quote. So maybe that's the way, a way we could solve this. We do /quote, and also we need to let's just do it for double quotes too, in case the user uses double quotes in their code. Okay, so let's see what would happen if we did this. Let's take the same input from before, and now what we do is we're basically searching in for anywhere we find a single quote or a double quote, and we're going to replace it with an escaped single quote in this case. And so yeah, this works. It turns this whole thing that the user typed in into a string, and it's going to look correct. It's going to be literally the string that we wanted. And yeah, I don't see any problems with this particular case. Yeah, question?
What if the last two backslashes turn into one backslash? Like in the string?
Oh, I think if they were backslashes, they would, but they're forward slashes in this example. Yeah. But actually, I wonder if you had two backslashes in the input. Yeah, I think it depends on the whether they were literally two backslashes that had already been escaped when they got to the server or not. But that makes sense? No, it's not that important. Okay, so this is what we got. But there's a problem with this. So can anyone think of a way to alter this input that would let me break out of this string? There's definitely a way.
Add a backslash before the first single quotes, like for Ross backslash. And then
So you want to do for Ross backslash quote?
Yeah.
Okay. So let's be clear here, though. So normally, if this is in a context that's a JavaScript context, doing /quote would just be treated as a quote, right? Because what you're suggesting is literally we want it to be the case that when the server sees the string, it's seeing an actual /quote. So maybe we have to put two backslashes in here when we send it to the server. But the point is, yeah, if the server sees for us /quote, then it's going to go ahead and run its algorithm, which is it's going to look for quotes, right? And it's going to swap them with /quote. And what is that going to do? Well, it's going to do this. So yeah, it found a quote and it changed it to /quote. And our backslash turned this backslash from what it would have been before is this would have been basically the start of a control sequence saying that this is not a real quote. But by putting this in front, what we've done is we've said, no, actually, this is not a control backslash. This is itself a literal backslash. And now we've basically produced the string for us backslash. And then this function, right? So are we out of luck? It seems like this is a really hard problem to solve. Does everyone see the problem? Okay, so this seems like a big problem. Ideas? What could we do? Yeah.
I
few backslashes?
Backslash the backslashes. Yeah, that's actually a good idea. Then let's see. If we did that, then I think you're right. That would turn this into a backslash, and then this would actually work. Yeah, that actually would. Okay. So that does solve this problem. But I actually have a couple more problems with this that we're going to hit. But but that does seem to solve it. I think I can't think of a reason why that wouldn't work. Yeah. Huh. Okay. But yeah, so to summarize the lesson, so avoid using backslashes because it can be neutered by placing another backslash in front. Your approach sounds like it could work. Here's another idea for a fix. What if instead of doing escaping the backslashes with another backslash, instead we just we also apply the HTML escaping, and then what we end up with is this. So now if I type Feroz quote, we're going to get Feroz a pause, and that now this will be when the HTML parser runs, this will be turned into a quote, but in the no, sorry, that's not true. Well, what's going to happen is right, because the way the HTML parser works is it's actually going to just identify that this is the start of a script and this is the end of a script, and then the JavaScript parser takes over and actually parses this as JavaScript. And JavaScript actually has no idea what ampersand a pause semicolon is. That comes from HTML. And so what we've actually done here is we've protected our code, but we've caused the problem that now like string just looks like garbage, and it's not what the user typed in. But I think we're safe here because we're sort of taking out all quotes. We've solved that problem. So yeah, the two problems are it doesn't preserve the user's input, so they get something that they didn't type in when it alerts out. And by the way, this is the alert that's supposed to happen because remember we're saying hi there username. So it's fine that this alert happens. We're just saying hi there, and then this should be what the user typed in, which is not what they typed in. So that's a problem. And also there's another problem here. It's still insecure. So let's talk about why that's the case. What about this input? Okay, this looks like a crazy input, but can people see what this is potentially doing here? Okay. Any ideas what this is doing? Yeah?
They're kind of like ending the previous script and then starting a new script.
Yeah. So isn't this like a syntax error though? It looks kind of like it would be a syntax error. Like why would it just stop there? Wouldn't it be obvious when the JavaScript parser is running? Wouldn't it be like, well, this has to be part of the string. It doesn't make sense. Like I'm in a string right now. How can I do that? Mm-hmm.
I mean, but the scripts are running like separately, right? So it might have broken the other scripts, but your script still runs.
Oh, I see what you're saying. You think that like this is an invalid script and this is an invalid script, but this one looks valid to you, so this is going to still run?
Yeah, because you're in the DOM context, right? So the DOM parses the tags using its rules, and the JavaScript runs inside the script tags.
Yeah, that's right. So I think what you're saying is that there's like an ordering, if it figures out the DOM first and then it tries to treat the contents as JavaScript, then it seems like we would have syntax error. This would run and then syntax error. Yeah. So that's actually what happens. Yeah, you're right. So if I just take the code from down here and I just reformat it so that it's a little bit easier to see what's going on, this is what we have, right? So as far as the browser is concerned, as far as the HTML parser is concerned, this is what the server sent to the browser. And it looks like we have an invalid script, a valid script, and an invalid script. And in particular, the ordering that the parsers run in matters. The first parser to run is the HTML parser. So before we can start to try and interpret the contents of those script tags as code, we first have to figure out where the script tags even are. So the first step is we look and we just find where all the tags are. That's what the HTML parser does. And it sort of just goes through and greedily looks for tags and produces a DOM tree. And when it does that, like it's going to look at this and just see 3 script tags. And it doesn't even care what the contents are. It doesn't look at that. It just says, as far as it's concerned, this is a string to be interpreted by the JavaScript parser later, right? So this is fine. The HTML parser is totally happy with this. Then the JavaScript and CSS parsers get a chance to run on the contents of script tags and style tags. And at that point in time, that is when we're going to get the error, the parse error here. And then this is a new context, so it has nothing to do with that script erroring. And so this gets a chance to run. And then lastly, this one errors out for syntax error. OK, so that is really wild. So now we basically have a problem where it's not enough to just escape quotes and think that we're safe, because we can also just get sort of escaped out of the script context by any closing script tag that appears anywhere in this source code. Yeah. Mm-hmm.
Sorry, I'm kind of confused. So since there is a syntax error, would it still run the second script?
Yes, because they're separate scripts. So like, say that you included a script to load some ad, and that script errored, it wouldn't cause the rest of the scripts on the page to not load. They're sort of independent from each other. This will basically throw an exception on the syntax error, which is not caught, and then you'll get a sort of print out in the console, and then the next script will run. Yeah. So anyway, this is crazy. By the way, one implication of this is that you actually have to be certain when you're writing JavaScript code that if you literally include this string left angle bracket, close and then script. Like if you have a closing script tag, if you have this string anywhere in your JavaScript, and then you paste that into a page, like where was that example? Here. Yeah. Like if you have this string just appears anywhere in a string in your JavaScript program, then it will break your page. It'll bust you out of the script context that you're in. So something to be aware of. Now, oftentimes we just include scripts by doing script source equals, and we load it from another destination, and that doesn't have this problem. Yeah. So anyway, this is crazy. So here's the fix. Here's at least one fix. There's two fixes that I know of. One fix is this. So you can hex encode the user's data. So hex encoding basically just takes the user's provided data and turns it into a different representation, which is only going to use the characters 0 through 9 and A through F. And so now, if you think about it, any possible combination of 0 through 9 and A through F in this context is safe. There's no way they can get out of these single quotes here, because they can't write a closing script tag, they can't write a quote, so we're fine. Then the thing is we have to undo that at runtime. So when the program first runs, it needs to sort of take this encoding and then turn it back into what the user originally typed in. And then we're sort of safe. We can sort of ignore a whole bunch of problems and not worry about any of those edge cases. Does that make sense? Yeah. So this is like one way to do it. But yeah, usually you actually usually see the unsafe way very often in real code bases for whatever reason. Here's a real example of what this would look like. So here's our template, and here's our user's malicious input, and we just hex encode this, and we get some giant string that looks like this, and we put it in there, and no problems at all. Here's another approach. So this is using a tag called template, and this is a new HTML tag that lets you basically, you can put whatever contents you want inside of it, and it won't render it at all. It's inert. It's just like you're just throwing some data into the page. And the only way to do something with the data you put in here is to retrieve the data from JavaScript. So in this case, I can get an element by ID, username. In this case, that's this template here, and I could put the user's username sort of into here, and I can retrieve it by getting its contents out. And so this gives me this, and then I can use it. And what's nice about this is that to escape contents inside of an HTML tag is really simple. That was the first thing I showed you. It was really straightforward. We know how to escape something that goes in between HTML tags. The only thing we have to escape are what characters? The left angle bracket and the ampersand. And we can put whatever we want in here. So that's a very simple rule. So you can just do this. Throw your data into a template tag and then pull it out from JavaScript. And then again, you can sort of not worry about lots of edge cases. Does that make sense? Cool. Okay, so a few contexts which are never safe. So never let the user put data in the script, like just in a sort of free-floating part of the script. That's just, you're letting them run code. HTML comments, that's kind of a weird one. Why not that?
Just escape the comment.
Yeah, they can escape the comment with the dash arrow. Say you escape that, you could. It turns out that the parser rules for this are just really annoying and hard, and it's just better to just not put user data in there. Like you have other ways. If you want to put user data, first of all, it's not going to even change the way the page looks because it's a comment. So just avoid owning yourself by being like, I want to put this into a comment. Like just don't do it. You might be able to figure out how to, but the rules were not easy for me to find. So the recommendation is just avoid it. Again, like tag names, this might seem like, well, what's the big deal if I let them name a tag and I just ban script, style, and a few other tags, but I let them put whatever tag name they want in here? What's the problem? Well, I mean, in general, if you take a block list approach, you're going to miss some cases. If the browser adds new tags tomorrow and you didn't block those ones, then that's a problem. But it turns out it's also because the browsers aren't consistent about how they interpret weird characters in here. I'll show you an example on the next slide where you can put like slashes and stars and different things in here and confuse the heck out of the browser. And here's another one. So attribute names, don't do that. And then style contents, don't do that. Okay, so here are some examples of really wild HTML you could write. So these are all valid as far as the browser is concerned. So it's very lax and very forgiving about the kind of HTML that you write. So in this case, this is interpreted as script space XSS space source blah blah blah. And why is this significant? Why would I want to write a tag like this? Well, if I'm an attacker and I know that you're doing, you're sort of looking for a blacklist of tag names that I'm not supposed to use, and I know you're searching for, let's say I know you're searching for angle brackets script space, because you think that all tags have to start with the name and then space and then so on. I can use slash XSS or whatever, slash whatever I want, and it's going to get past your filter. And the browser, though, is going to sort of treat this as a space. And so you have sort of differences in what you're looking for versus how the browser is going to interpret it. And so there's a lot of examples like that that you can use other characters in that case. This one here is a really wild one. So in Firefox, all these characters just get ignored. You can have sort of anything you want between the end of the name of the attribute and the equal sign, and it'll just ignore it. And so again, if you have a block list approach where you're trying to block names that you don't want, this is not going to match your name. Onload is, if you banned onload, you might allow this through, and then you let them actually run code. And then these ones down here are really wild. This is like you don't even close, you don't end the tag, you actually flip it around, and and then I don't even know I forget what this one does, but yeah, this actually runs the script for some reason. I don't know how it's actually parsed, but yeah, anyway, it's just the HTML parser is very forgiving. So the reason why it was designed this way is because of this idea called the robustness principle. And the idea is, if you're trying to make a robust piece of software, you should be very conservative in the values that you produce and be very forgiving in the values that you accept. If you do that, then your software will work it will work better if you do that, is the idea. So the idea is this comes up a lot in networking contexts. So say that you're writing a TCP implementation and you want to work with as many systems as possible. Well, say that somebody sends you a TCP packet that's actually malformed, like it doesn't follow the specification. But you can still figure out what it's doing. Like you kind of know, I know what they mean, they're not following the rules, I'll just kind of fix it for them, and then I'll run with it, That's actually, in a way, good for your users, right? Because now you've made your software more robust. You can talk to more systems, right? And your users will be happy, right? In fact, if you refuse to fix that, if you just say, I'm going to throw an error when I get a malformed packet, your users are going to complain, like, hey, I'm trying to talk to this computer and it doesn't work, right? So there's actually this sort of pressure to make your parsers more forgiving, to accept more inputs from people. And then the sort of flip side of that is, as much as possible, if you produce valid outputs, so in other words, you send packets that do follow the spec, then everybody you talk to should be able to understand it, because you're sort of following the rules very aggressively in the stuff that you produce, while being forgiving in what you accept. Does that make sense? So yeah, that's the idea. But the thing is, it's actually really bad for a couple of reasons. One is, for security reasons, you're now sort of having to guess about what some input that you've received means, and you're making some assumptions potentially. And also, you get this bad behavior where somebody can write an implementation. Here's an example. Say that, and this is actually how it happened in the early days with browsers. If you wrote crappy HTML that was wrong, the browser would just be like, I know you meant to close the tag there. I know you meant to, I know, it would just sort of fix things for you. And then you wouldn't know that your code was wrong, right? You'd open it up in Internet Explorer, which is what everybody was using, and you'd be like, it looks great. And then Firefox comes along and wants to make an alternative, and they write a browser that follows all the specs exactly, they follow all the rules, how to parse HTML, but when they load up normal websites that people have coded and they look at it, they say, wait a minute, it doesn't look right. So now suddenly Firefox has to guess what the users meant in the same way that Internet Explorer was guessing what users meant, right? And if they don't guess the same way, then the sites are going to look different in the different browsers. And these guesses are not documented or specified in any way. It's just sort of engineers at Microsoft just sort of hacking, just guessing, maybe they meant that, whatever, and so you get the situation where the bugs or the sort of implementation details that one browser vendor made have to be reverse engineered, and the bugs have to be copied into the new browser just so that existing sites look like they work. And so this is just, it's in the end actually a bad idea, even though it sounds good. Like robustness principle, No, it's actually, it's better to error right away, and then people can know that their code is broken and they should fix it, and we can all, be happy. So anyway, TLDR, you can escape user data safely in these 3 contexts, avoid the other ones. Just a few final notes. So beware of nesting parsing chains. So you can see in this example, we have user data that's in a string in a function that's in a string that's passed to a set timeout that's in an attribute of an HTML element. So if you do that, and you're trying to figure out how to escape this, you're going to have a hard time. Basically, the browser's going to do this. It's going to pull the on-click attribute value out and treat that as a string, attach it to the DOM node, and then later, when somebody clicks on this div, then it's going to say, that's a string that I need to now turn into JavaScript. And so it's going to parse it as JavaScript, and then it's going to see, they called set timeout. Okay, cool. So it'll start a timer, and the timer is set to run the function in 1 second. And the parameter to set timeout is also itself a string. And so then 1 second later, it's going to be like, okay, now time to turn the string into JavaScript, and then run that. And so you actually have to escape your input 3 times. The first 2 have to be JavaScript / sequences, and then the next one has to be HTML encoded. And if you don't do that exactly right, then you're in trouble. So just don't nest things deeply and write code like this. This is actually surprisingly common. Another example. This is an example where you might think, it's straightforward. Like this is a string in JavaScript. We already talked about this. I know how to escape this. The problem, though, is that we're then taking that value and putting it into a different context here. And so it needs to be then escaped 1 more time here if we're gonna use it. It's not enough to just use it in this place. So yeah. So let's see, what do I have in here? I'm running out of time. Oh man, that's a huge bummer. Because so I'll save this for next time. But so now we have a good idea of sort of all the different ways you could do XSS attacks. Next time I'm going to show you. This is so cool. So there's this Chrome feature called XSS Auditor, which it was a great idea initially. It was the idea was if we see that the user is making a request to a URL and there's some script in that URL, and then we see that same script in the page that the server produces, then it's very likely that that's a reflected XSS attack. And so they're like, we can just disable that script and save the user from being attacked. But it turns out this actually helped attackers so much. Like it created so many different attacks, and I'm going to show you some of those next time. So cool. See you next Tuesday. Oh, and one last announcement. There's a speaker coming on next Thursday. That's the guy from Brave, and he's going to talk about fingerprinting. So that's a guest speaker. Feel free to invite your friends if you think they're interested in browser fingerprinting, user tracking, anything like that, privacy on the web. It's open to anybody. Cool.